Okay, hello there. This video segment is going to discuss and explore two special logarithmic bases. Okay, so this is logarithm basics, but we're really talking about two special logarithm bases. So if you're going to look at your calculator, you would notice that any calculator that is equipped to calculate logarithms is equipped with two specific bases. Some of the newer calculators have operating systems which allow you to put in any base you want, but if you have any calculator that does logarithms, it will have two specific bases pre-programmed. And so it becomes very helpful for us to learn how to deal with the bases that our calculator will handle. And those two bases are base 10. Okay, and you would probably understand that this is a very good base to learn to deal with because it's very, very easy to bring to powers, both positive and negative, because of the nature of the number 10. And also the transcendental, all-powerful number E. Okay, so when we are discussing these logarithms, they are so special that they have their own notation. Okay, if I'm talking about a logarithm with a base of 10, we don't even need to write a base. Okay, so if you see log of x, it is the same as log base 10 of x. It is so common that we don't even need to write the base, and therefore it is called a common log. Okay, when we discuss logarithms with a base of e, so something along the lines of a log base e of x, what we do, instead of writing the log, we say that this is ln of x, otherwise known as the natural log of x, or log natural, which I think is where the ln comes from. Okay, so this allows us to handle some logarithms that may have looked a little bit intimidating before by knowing these notations and knowing their equivalencies. Okay, so we're going to look at some examples together, and this should go pretty quickly. We're going to look at something like this. What is the ln of 1? Okay, well, that goes back to what we talked about in the last segment. Anything, the log of 1 with any base is equal to 0. Okay, and this could be thought of as log base e of 1, but that base does not really matter here. Okay, how about the ln of e? Okay, so this is really saying what is the log base e of e? And remember, when those bases are the same, that is the same as it being equal to 1. Okay, what about log of 1,000? Okay, so remember that when the base is missing, it's the same as having a base of 10. So this is log base 10 of 1,000, or what power of 10 is 1,000? And of course, the answer to that is 3. Okay, so now let's look at some things that are a little more complicated, but you can handle them. All right, how about this? Log base, I'm not going to say the base, log of 10 to the 7th power. What is this equivalent to? Well, this is the same as log base 10 of 10 to the 7th. And remember, when we do that, that's the same as the bases canceling out because the bases are the same. And we're left with just the exponent. Okay, how about ln of e to the 6th power? Okay, so what is the base of this logarithm? It's e, right? So log base e of e to the 6th, that is equivalent to just 6. All right, how about this one? ln of e to the 13x. What is this equal to? And the key to this is thinking about it in terms of what is the base of this logarithm. This is log base e of e to the 13x. And again, recall that anytime you have a common base with both an exponential expression and a logarithmic expression, they are inverse operations, and we're left with just the exponent piece. Okay, last one of these, and it's going to look really scary, but it's really not. Okay, so how about 10 raised to the log of the cube root of x? What is that equal to? Okay, so many of you are starting to catch on that this has a base of 10. So we have a logarithm with a base of 10 and an exponential expression with a base of 10, so we're left with just the exponent. All right, that's it for the special basis, and we'll see you next time.